So hello everybody, this is VJ and you are on MSane. So today we are going to discuss COVID-19 data analysis using Python. So the prerequisites of this course will be obviously basic Python programming language and some of the libraries such as Pandas, NumPy, Seaborn and Matplotlib. But even if you do not have quite a knowledge about these libraries or you have not heard about them, do not worry, I'll explain each and every bit of code so that you understand this project by yourself. Also, what we are going to do in this project is like we will be comparing two CSV files. So one CSV file will be the number of infection rate. So for each and every individual day, what were the highest numbers of cases that were recorded of COVID-19, and what were the from January to this June, for each and every day how many number of cases for each and every country. We have covered around 187 countries in that module, in that CSV file. So we have that CSV file, and the another CSV file that we have is the World Happiness Report CSV file. So the analysis or the prediction of this particular project will be like what we want to find with this analysis is that whether COVID-19 is spreading like very rapidly in developed countries, or it is spreading more rapidly in non-developed countries. That is what we want to find with this analysis. So we'll do that. Also, when we'll check the link in the description, you will find this file which will be COVID-19 data analysis notebook practice, which is blank, but we have mentioned all the tasks that you need to perform, so you do not worry about what we are supposed to do. Also, we will guide you. You can watch the complete video and you can understand. The another file that we have in that module is there are two more CSV file apart from this Python file. You have to open this one into a Jupyter notebook or in Google Colab itself. You have to make sure that when you open it in your Google Colab, you have to mention the right path. So you should be knowing how to open a file in Google Notebook, then only you will be open to open it. If you do not know, you can definitely check out some videos on how to open a file with Google Colab, and you can do that. It is very simple. You'll find n number of videos to do that. So in my case, in the for this analysis, like we have stored all our data in dataset folder. We have this file in this dataset folder. We have the other two CSV files in this dataset folder. So you need to understand that there are total three files. The first file is this one that we are working on. The another file is a CSV file, and the third file is also a CSV file. Now what are those two CSV files? The first one is the World Happiness Report CSV file, and the another one is the number of infection rates, that CSV file. And we have one more CSV file that you have to use for practice. We'll talk about it later in the video. So let's start with the video. When you'll open this file, you'll find that we have imported all these libraries. Okay, so we have Pandas imported, we have NumPy imported, we have Seaborn imported, we have Matplotlib imported. And if this code, this 4 line of codes run successfully, then we'll print modules are imported. So let's do that. Okay, also I have already done that. That is the only reason why it is showing in output modules are imported. Yeah, so in my case all the modules are imported and we do not have any error as far as this part of the video is concerned. Now we'll move ahead. Task 2 is importing the COVID-19 dataset. So we have to write some code to import the dataset that is stored in this file. So what I'll do is I'll name a variable corona and dataset CSV, and then using pandas we have a method which is pd.read CSV. That is the name of the method. So what it will do is, pd.read CSV is the matter of the pandas, and corona dataset CSV, this is the name of the variable that we have assigned. Now here we need to mention the path where our file is stored, so that it can fetch that file and use it. So my file is stored in dataset. Obviously this part of code will change for you, because you have to find where your file is stored, where you downloaded it and where you stored it. Try to store it into one folder. You can make a folder in your computer where you can mention projects, and then you can keep all these files. So this is the name of the file, confirmed dataset.csv, COVID-19 confirmed dataset.csv. Okay, we got that. I just pressed tab and it came automatically. So we are done till here. We have this another function, that is head function. Okay, so what head does is it will display. So for example, your code have your file has 187 or 200 lines or rows in the file, but you only want top 5. So what you'll do is you'll use head function. So we have this variable corona dataset. See, we'll get that also, I guess, after I press the tab. Okay, it is not working now because we have not used it. So yeah, corona dataset underscore corona underscore dataset set underscore csv is the name of the variable, and dot head is the function. Now I'll run it and you'll see top 5 rows of the file that we have. Let's do that. So it is saying corona dataset csv is not defined. And why is it saying that? So we made some mistake or what? Oh yes, corona should be the name. Yeah, now I'll run this. Yeah, so we got this top 5 files, top 5 rows from our total dataset, and you can see this. There's Afghanistan, Albania, Algeria, Andorra, Angola. So likewise we have like 187 to 200 countries. We have covered all of those. So we have latitude, longitude, we have province, state, and these are the dates from 1/22/20 to 4/30/20. We have covered all these dates. Okay, so now we'll check the shape of this dataset. Let's check the shape of the data frame. Okay, so what we'll do is we have our corona dataset csv. We will use shape function on this one. So when we'll do this, so we'll get the shape. So okay, I was saying 200, but there are like 266 countries which we have covered. But also when you'll see this whole, like if you open that csv file, you'll find that there are some columns or rows where country name is not there, only state and province name is there. So we'll do that also. We'll delete the useless column, we'll do everything, do not worry about it, and we will only find the name of the countries. We'll use only those rows where a name of the country is there. So now we are supposed to delete the useless column. So what is a useless column in this file we have? See, we have latitude and longitude. We do not want that. I just wanted the name of the countries and the data. I do not want the physical location of the country. It could be useful for another analysis, but for this one I do not think it is that much required. So what I'll do is corona dataset csv, that is the name, that is the variable, and now I'll use a drop method. So in drop method I have to write the name of the column that I want to drop. So first one is the lat, you'll see here, first one is the lat, second one is the long. So I am doing that only. So I have mentioned lat, now I'll mention long. Alright, now I am using axis is equal to 1. Now what is axis is equal to 1? So what axis actually is, when you use axis is equal to 0, it defines rows, but when I am using axis is equal to 1, so what it will do is it will delete the whole column. if you would have used access is equal to 0, it would have only deleted lat, I mean only this one. But when you said access is equal to 1, you are specifying that I want it to start deleting from here, but I want to delete all of this, I mean this one, and then this one, and then this one. So access is equal to 1 is equal to specifying that you want to delete the whole column. That is what access is equal to 1 does. Now we'll use this another thing called inplace in place is equal to true. What in place is equal to true does? Now see, corona dataset csv is the name of the variable, I mean is the file where we have stored our we have opened this file and we have stored it into this one. So in place is equal to true, what it will do is it will make changes to the original file, I mean not this file, but we have extracted it, we have opened it, and we have stored it into this one, corona dataset csv. So now you do not need another variable to perform actions. Like whatever we do, we have dropped latitude and longitude, it will be dropped by this file also. So we can use corona dataset csv where these two columns will be dropped. That is what in place is equal to true does. Now we'll again see the dataset and we'll find whether what we did was done or not. So I told you we have this head function to always see. Now this time I do not want 5 rows, I want 10 rows. So I'll mention 10 inside the head function. Now I'll run that and you'll see 10 line of code. 0 is also there, so we have from 0 to 9, 10 number of rows, and we have latitude and longitude as well. Why is that happening? This is quite a strange. We did not run this code, I guess. Okay, now let me see. Yeah, so now when you'll see this, you do not have a latitude and longitude in this file. So you got it? When I did not run this code, it was the original one only where we had latitude and longitude, but when I when I ran this line of code, it dropped the latitude and longitude columns. So we have this data set where we do not have latitude and longitude. Now we'll aggregate the rows by the countries. What is that? So for example, I do not want this province and state, and I want my dataset to start. I don't want this. I do not want this. I want just the country name. So how will I do that? How will I make sure that my dataset starts with this column, with country column? So what we'll do for that is we will make another variable this time. You may think that why am I doing that? Why am I not making changes to the original one? Well, you will get to know why am I doing that. So it will be aggregated, right? So yeah, corona dataset aggregated is the name of the variable, and that corona dataset csv was the original one. And now I'll use groupy, group y. I'll use group by function, and there I'll find from where, from for which column I want to group by. So the name of the column is country/region. I'll mention that in this one, and then I'll also use sum. Okay, so what this whole thing will do is, we had this corona dataset csv, we have used group by function, and then now what will happen is these two columns will be eliminated and our dataset will be grouped by according to the country and region column. That is what this whole line says, and will store that result into this one. So whenever I'll use corona dataset aggregated, I'll see a dataset where it is grouped by according the country/region column. Okay, so now it's time to see what we did. So I'll use aggregated one, AGGREGATED, and then we have the head function. I only want 5 is enough for me, Aggregated is not defined. I may have made some mistake. Did I not run this? Let me see. No. Okay, I made a spelling mistake. Do not make spelling mistake, guys. I do this very often. Okay, so here we got it. So it is now you can see the difference between the this one and this one. What is the difference? You do not have province slash state. Also, you do not have these numbers in this data set. So we have grouped by according to country and region. For this one we have country and region, and here are the dates. That is what we've always wanted to do. Now, do you remember what was the shape when I checked the original dataset? After importing it, it was 266 comma 104. So 266 are the rows and 104 is the column. Now I have grouped by it according to country slash region. Now I'll again check the shape. Okay, so we have corona dataset aggregated, and shape is the thing. Shape is not a function, guys, so do not use this after shape. You have to just write shape and it will do the job. So it is 187 comma 100. Now that is the only reason why I told you that we will be covering 187 countries. So do you now know why it happened? Because there were some, so we have only covered 10 columns. 10 columns, but there were around 266 columns. So in those 266 column, there were some rows where there was no country but only province or state. So it eliminated those country and state, and it only covered those rows where it had a valid country name. So now we have valid 187 countries with their data sets, with their data of individual days from this date to this date. Okay, now we will be visualizing some of the data. So now we'll be visualizing some of the data for you to understand what we are actually going to do. So we have our data into corona dataset aggregated. Let's write it down, corona dataset aggregated, and now I'll use the LOC function. LOC means locate. So I'll use the LOC function, and inside LOC, for example, I want to visualize for China. So China is the country name, column name. You can write that, and we'll use plot function. This plot function comes from matplotlib library that we have already imported. Okay, so this was about China. I want it for Italy as well. So what I'll do is I'll just copy it down, I'll paste it over here, and I'll write Italy. That is how it is done. Also I want it for Spain, China, Italy, and I want it for Spain as well. So yeah, now when I'll run this code, so it says, did I mention a wrong spelling? Oh my god, yes. Okay, so we have got like 3 lines in this one. So we have got a blue line, we have got an orange line, we have got a green line. Now the problem with me is I do not understand which line is, which one. So what we'll do for that, what can we do for that? Can we do something? Yes, we can. We can always find out like which line represents which data. So we can use the legend function. So PLT is the library for matplotlib, and we'll use legend legend function for this, and then we'll run it again. And now we have you must have seen this in your graphs in your childhood days. So that is what the legend function does. It specifies the name. Now we'll calculate a good measure. So what do you mean by that? We'll calculate a good measure means we will try to calculate so what do you mean by we will try to calculate? See, For example, there we have, you can see that after 0 we have I mean 50,000, and then we have 1 lakh. So there's a difference of 50,000 in the numbers. That is not a good measure. We want to scale it down to a little bit. I mean, we want a little lower measure for that. So what we'll do is we'll again plot a graph. Corona dataset aggregated is the variable name, and then we have LOC, and in LOC we have to write the column name, that is China, and we have PLT method. Okay, this I already did, right? Again, I made some mistake. It's plot. Okay, it's not PLT. Alright, so we have this graph over here. Now what am I supposed to do? I want it to scale it down to a little bit. How will I do that? So for that I have to use the same variable name, Corona dataset aggregated, and I'll again use the LOC locate, and I'll write the column name. LOC means locate that particular column. So if you're using it for some another dataset, you have to make sure and you have to understand that LOC means locate this particular column for me. That is what you're saying. After this we will write that I want to start it from with any number. I mean, this is slicing in Python. You should be aware about what this colon and 3 is, but then also let me tell you that this is string slicing in Python, and if you do not know this, you should learn this. And then we'll use the plot function. So what it will do is it will scale it down to a little bit. I'll run this one, and you will see there's a change in the graph. Now why is that? So we had this graph for 0 to 80,000, right, for the total number of cases from this one to the last one. Now we have scaled it down to a little bit. We have it for like 22, then 23 and 24. So for it started for January 22, then January 23, then January 24. Only for 2 days it is. And now we can see that what was the change in these 2 dates. So for January 22 it was around 550, and then in January 23 it touched around 650. So we had like 100 cases more, and then January 24 it was around 900. So you can see this drastic change in the graph, and that was possible because we scaled it down to a very granular level. It was for like 4 months, and we scaled it down to 2 days. So that is crazy. Now what we'll do, we will calculate derivative curve of this graph. Now what is a derivative curve? What is derivative curve is actually, so for we have like this data set for 4 months, for January 21 22 till till March, 11th of April we have, right? So what we'll do is we'll calculate the derivative curve. And what is a derivative curve is, in those 4 months, what was that particular day where we had the highest number of cases for that particular country. So we'll calculate that, like what was that particular day where China witnessed one highest cases, and that those highest cases will be calculated like there were no previous day where the number of cases surpassed that day, and after that also there were no number of cases which surpassed that day. So that is what will be the first derivative of the curve. Now how we will do that? We have to use our variable Corona dataset aggregated, and then I'll locate the column whose name is China. I'll do that. Yeah, that's how I did it. And then I'll use diff function. Diff function, usually what it does, it creates a differential, and then I'll plot it. So any for if you want to create a data set where you want to find a number of the column which is the highest, for example, if your data set contains price of the fruits, and you want to predict like which fruit has the highest price, so you can always use the diff function and it will predict that for you using a graph, because you are plotting that also. That's what matplotlib does. Now I'll run this code, and you can see that what was this date? This is February 11. After February 11, somewhere over here, it surpassed around 14,000 cases for a single day, and before and after that highest was the 5,200 or 500 something, and then here we have 1,500 around. And there were no, there were no dates where the number of cases surpassed this date. So this was the most, crucial day for the infection rates in China. That is what we got. Now find maximum infection rate for China. How will I do that? Using this graph only. I have plotted it, but now I want to find it out. Like, I'll use the max function and I'll find it out. How we'll do this? We have our data set already. We have used it many number of times. So corona dataset aggregated. Now we will locate. Okay. So we'll locate China. And then this time also I'll use the differential function. That is what differential does. It will it will predict these kind of data. This time I'll not plot it. Instead I'll use the max function and I'll find out what was that particular number. I don't want to see it into a graph. I want that exact number. So what this number that we saw here was 15,136 cases on one single day it witnessed. Now do you remember, like we mentioned, we had used, we have located another countries as well. So let's do that also. Let's find the maximum number of cases in a single day for some another countries as well. I want to find it for Italy, because Italy was so much into news and everything, that there was so many cases and this and that. So let's find it out. Like, let's do that for Italy. So the maximum number of cases for a single day for Italy was 6,557. Remember, for those 4 months from January to April. If condition may have worse, if condition got better or worse, we do not know that, because we have data for only 4 months. Now also I want to use this data set for India also. Let's do that. INDIA, and let's run it. So we had 1,893 cases for a single day for the whole country India, but for those 4 months from January to April. So we have learned how to use the max function, how to use the diff function. Now we will find maximum infection rate for all of the countries. So how will I do that? First of all, I'll create a list. Okay, so I'll use a variable. I want like our corona dataset aggregated. I want it to be indexed. Okay, so I did that. Now I want to create a list of this corona dataset aggregated index. I want a list to be created of it, and I want to store it into countries. Okay, then I want to create a empty list where the name of that list will be maximum infection rate. Maximum infection rates is the name of the list, which is an empty list for me. Now if you know Python, we will be using loops in this one. I'll explain you that as well. For C in countries, so what we did is we have indexed the index was the name of the countries. From the corona dataset aggregated, we have fetched the index and we have stored it into countries for C in countries. And then we created a empty loop which was max infection rate, and then I am using loop for C in countries. What it will do is it will loop inside this country, and we have this empty list which is maximum infection rate. Yes, we will append every name of the country that it loops through, will append that into this. And we have corona dataset aggregated, and will pass C inside it. I'll not name any particular country in this one. Why? Because I do not want it for a particular country. I want to make a I mean I want to make a list maximum infection rates where we'll have the maximum number. So we'll have maximum number for China, we'll have maximum number for Italy, we'll have maximum number for India. We'll use it that way. Okay, so here we did that. I mean, you are very familiar with this line of code, corona dataset aggregated, and then inside it you have to write the column name and then diff function and then max function. What it does, you already know that it finds you the maximum number. It searches all the columns and it will find the maximum one. Okay, and then it'll append it into this list, which is max infection rate. Also we use this for loop for C in countries. We already used a list to fill the name of the countries into this one, and that's how it is done. So if I'll run this, what we'll get a list maximum infection rate which will have maximum number of infection rate for all of the countries. Okay, now what I'll do is, we have a corona dataset aggregated that we had, corona dataset aggregated that we had. Now from that I will pass inside it max infection rate, that is our list name, max infection rate is equal to max infection rates. So max infection rates is the name of the list, max infection rates. So max infection rates we'll use here max infection rate. Okay, all right, and now when I'll run this one, let's see what happens. Okay, we made some mistake. Now I have to find what mistake did I do. Max infection rates dot append, and then we use corona dataset aggregated and diff dot max, then corona dataset aggregated max infection rate is equal to max infection rates. I do not see any mistake in this one, but we definitely did something. That is the only reason why it is showing error. Okay, what is the error it is showing? No, give me a moment guys, let me check what mistake I did so that I can explain it to you as well. Definitely it will not go there. So we have countries, we have list corona dataset aggregated dot index, then we use max infection rates, we use that for C in countries, max infection rates dot append corona dataset aggregated. Oh, we did not use LOC function. How is that possible? I mean, how will it run without that? That is the error that we were doing. Okay, we got it. Now it is running guys. Now what I'll do is, I will again use corona dataset aggregated dot head, because we have stored what we did with corona dataset aggregated is, we had this max infection rate and I use that max infection rate to get stored into this one. Okay, so now when I'll when I'll use corona dataset dot aggregated and we have the head function, when I'll print this, a new dataset will be printed where we have the maximum number of, see, so corona dataset aggregated was our file name, and maximum infection rate was this new list. So I appended max infection rate. This is the name of the column that you can see here. I uh, I created a new column in this one, max corona dataset aggregated, and the name of the column is max infection rate, and the data it gets from is from this empty list which was filled by this process, and then I added max infection rate ka data into this one, max infection rate. That is what it does. Now we'll create a new data frame with only the needed column. Now for example, I do not need all this data. Now, we have data for all the dates, but I do not need it. I only need it for this particular one. So I'll which particular one? The last one, which we created just now. I only need the maximum infection rate, max infection rate. So I'll create a new variable which will be corona data. So then I'll use the pandas pd.data frame. That is one of the methods, and I'll pass inside it corona dataset aggregated, which is the name of our file. Corona dataset aggregated it is, and inside it I'll pass this one, that I only want this one. I do not want any other ones, but I just want this one. That is why what I told him. Now when I'll run it, corona data will contain only the last column, and I want only that one. So we have corona data dot head is the function that you know. Now what will be the output of this one? The output of this one will be the name of the countries and maximum infection rate, only this much, and we only wanted that much also. So our task is done till here. So do you want to me to revise what all we did? We imported a data set, we deleted the useless column which was latitude and longitude, then we aggregated it, that we wanted to start with columns, we did that. We visualized some of the data, we plotted graph for China, Italy and Spain. Then we calculated a good measure, means we reduced this column from 4 months to 2 days. That's what we did. Then we calculated the first derivative, the maximum number of cases in one particular day. We calculated in numbers as well for China, Italy and India. And then I appended a new column, I would say, max infection rate, into the data set that we already had. Then I extracted maximum infection rate, the new list that we calculated and appended, and the name of the list, only those two, into a new data set which is corona data. Now what we'll do, now this is now some of the task will be repeated. So now we'll import a new data set which will be world happiness report.csv. Now this particular file is also available in the link in the description. You can find it from there. So the name of this one is happiness report csv. This is a variable name, guys. Okay. Now pd.read is something that we already use while reading the first one, earlier one dataset, and dataset is the folder name where all my files are stored. So dataset it is, and then we have world happiness report.csv. That is the name of the file, world happiness report.csv. It is not reading it, I guess. I have to write it manually. Worldwide and happiness report.csv. That is the name of the file, guys. Now when I'll run it, I do not want to see any errors, but there's no module named read. How is that possible? Oh yeah, there's no module named read. Instead it is read csv. Okay. Now I'll run it and it creates more error. I did some mistake, I guess. It was datasets. Now I'll run it and I do not have any errors. Now I have this variable which has the data of this file. Now I'll look at the file. So head is the function to use, and yes, so we have this world happiness report which consists of so many columns, and the name of and the columns are GDP per capita, social support, life health expectancy, freedom to make life choices, generosity, perceptions of corruption, and all of these. So all these numbers define that how happy the citizens of the country are. Now we'll drop the useless columns just the similar way we dropped latitude and longitude from the previous ones. Using the same method, same everything, we'll drop. Now I do not want to write the whole code, I just want to copy it down. You do not do this, you please write the code. The more you'll write, the more you'll learn. Never copy your code, guys, not from Stack Overflow also. So we have Corona dataset CSV, but we do not want that. Instead we want happiness and report and CSV. Then we use the drop function. Now what are the name of the columns? We have overall rank, I want to drop that. I'll paste it down. Okay, after overall rank we have score, so this one is that, and after score we have GDP per capita. Let's do it for that as well. And after that, after GDP per capita, what do we have? So we have score, and I do not want generosity also. Let me remove that as well. After generosity I do not want perception of corruption also. Let's remove that. Okay, actually GDP per capita is important, I think. So I have removed overall rank, score. Let's not remove GDP per capita. Let's see. All right, so we have this. Yeah, so these columns will be deleted from our dataset and it will be stored into the same file, and then HAPPINESS happiness report CSV dot head. Yeah, so now, oh, did I not run it because I see the same file? Yeah, so overall rank, score, generosity, and perception of corruption, these four ones are already removed, and we have this new data set. The column which we do not wanted, they are not there anymore. Now we'll change the indices of the data frame. So what do you mean by that? I mean, you already know it. I do not want it 0 1 2 3 4. I want to start it with the country name. So we already have the HAPPINESS happiness report CSV, we have that, and we will use set index function. We have set index function in this one, and after that we have country or region, that is there, and I'll use in place. In place is equal to true. Right, so what it will do is it will eliminate this one. Instead my table will start from this column. Now I'll use again the head function to read it. Okay, let me run these ones. Yeah, so now it starts from this one. Now we will join. Now this is a very crucial step, guys. Now we have Corona dataset and we have World Happiness Report dataset. So we will see the corona dataset again. This time I want to see corona data, this one that we created the last time, corona data and head function. So yeah, this data we have around 187 countries in this one, but it will only displaying us the 5 countries. And also I'll see the shape. So we have corona data dot shape, yeah, 187 and 1. Now we have world happiness report dataset. So happiness report CSV is the name, happiness report CSV, and we have head function. Just a second, yeah. So this is the data that we have. Now I'll use the shape. I want to see the shape of this one so that it becomes easy for me to combine both, and we'll move ahead with the prediction, with the analysis that we want to do. So there it is 187, but here it is 156. Now what should I do? I will use inner join. Now if you know data structures, you'll know what inner join is. Basically we'll inner join both the datasets so that they can combine the countries. It will find the name of the countries from this one and the name of the countries from that one, and that data will be combined with this one. Data structures is one of the most interesting thing, guys. If you do not know, you have to learn it. You should learn it. So we will use corona data, the another one, corona data is the variable here, corona data, and then we have join function, and inside join function I'll use this happiness thing, happiness report CSV. And now how we want to join, how we want to do this, I want inner join for this one, not outer, not the other one. We want inner for this one. Okay, now again this data dot, I want to read it out. So let's, yeah, so what do we have now? Do you see something strange? Yeah, GDP per capita, social support, healthy life expectancy, freedom to make life choices were the columns of the happiness report.csv file, and max infection rate was the column of corona data.csv file, and we have successfully joined both the data sets. Congratulations to all of you. Now we will use a correlation matrix. What is a correlation matrix? You will find it out. We have this data set, we will use CORR function and we'll run it. So we have this correlation function. What correlation function does, so for example, maximum infection rate to maximum infection rate, it is 1, it means a positive sign. GDP per capita to GDP capita, it is 1, it means a positive sign, obviously, because these two are same. But when you find a larger number, for example, GDP per capita of a country and healthy life expectancy of a country is around 0.8630, so it's a positive sign. If you see some negative number or very less change in the number, or somewhere around 0.1 or 0.2, that means that thing does not affect, example, maximum infection rate, and we have 0.250, so it is not that much. But social support and GDP per capita 0.75, that is too much. So that is what correlation does. It will correlate the columns with each other, and it will find out where we have a positive sign. That's what we want to do. We want to make sure, we want to find whether there's a positive sign, there's a positive momentum between these two things. We have to find that. Now we'll visualize our result. So how to visualize that? So for visualization I'll be using scatter plot. So scatter plot is something that will give you it uses dots to visualize, and we will be using that only. So let me create a data variable x and y. What will x contain? X will contain GDP per capita, GDP per capita, CAPITA, GDP per capita, and y will contain max infection rate, max infection. So we have sns dot scatter plot here, and we have x comma np dot log. I mean, see, sns dot scatter plot, it takes two arguments, x and y. X will contain GDP per capita, y will contain max infection rate. But when you will see y, we want it. So let me tell you, let me show you what this function does. See, so there's only one a common thing between max infection rate and GDP per ratio. There must be only one point where they are meeting. Now the problem with max infection rate is we want to scale it down a little bit so that it matches with the GDP per capita numbers. So we will use numpy's log function over this one. So np dot log is the method, np means numpy, and dot log is the function. And when I'll run this one, it is creating error. Now why is that happening? It says log not supported. How is that possible? Let me see, guys. sns dot scatter plot. Let me try to run it once again. Just give me a moment here. Let me find it out. Okay, I got it. So whenever you want to, I wanted to use x and y for my scatter plot, right? And I wanted to use these columns, GDP per capita and maximum infection rate, but I did not mention from where these columns are coming. So I have to mention the name of my data as well, that is data. So data is the name of my dataset. From data you have to fetch this GDP per capita and you have to store it into x. From data you have to use max infection rate and you have to store into y. And then you have to plot a scatter plot which takes x and y, and then in y also I use np.array, which is a numpy function, so that it scales down a little bit and it matches with this one. Now let's do this. Yeah, we got it over here. So this is the relation between. Now you must have seen that for we had this number for like 0 to 50,000, and this log what it did for 2, 4, 6, 8 and 10. This is the number of infection. This is the number of so we had 2 patients, we have 4 patients, we had 6 patients. Earlier it was used to be 0 and then 50,000 and then 1 lakh. That's what there's a drastic change in that one. And why we did that? Because this number is very small. GDP per capita for a single individual, GDP percentage is like 0.50 and then 0.75 and then 1 and 1.25. So if the number of GDP, this percentage GDP per capita increases, this number is also increasing. But we have 2. So for 2, what is the GDP per capita? 0.25. So for 2, what is the GDP capita? So it's somewhere between this. So for 2, what is the GDP per capita? Somewhere more than 1. This is how we did it, and this is what the log function did. Now this is done, but we have this data, but is it supporting our analysis? Definitely we are. Like, I am able to see a positive sign, a positive graph in this one, but we have to find a line. See, there's a positive sign, this, and then this one, and this one as well, and then this. So we have to find a positive sign, we have to find a positive line which will support our analysis. So let's do that as well. Now in this I'll create another plot where I'll not use a scatter plot, but I'll use reg plots. What reg plot does, it will create a line in this dataset. So let's do that. sns dot reg plot, we'll use that, and we have this x and y, and for y also I'll use the numpy log function. We got it. Now when I'll run it, you can see this line. So what is this line? This line is actually the points where these predictions are matching. So we have a positive line. If this line would have been negative, this means that when GDP per capita is increasing, maximum infection rate is decreasing, which means that if a country is more developed, what is GDP per capita? GDP per capita means how much money country have for a particular individual. How much is the production, how much is the revenue, how much is everything, how much is the growth of the country for a particular individual. So that is what GDP shows. But we are able to find that when the GDP of per capita, I mean for a particular individual, when the GDP increases, maximum infection rate is also increasing. This means for developed countries, maximum rate is increasing, because when GDP per capita is increasing, it means that country is developed. When GDP per capita is decreasing, it means that country is underdeveloped, or when it is stable, it means that country is underdeveloped. That is what it means. So we have did that. Now I will use this plotting between maximum infection rate and social support. Social support means how the individuals, how the civilians of the country are supporting each other. So if they support each other, whether the maximum infection rate is increasing or decreasing, now we will find that also. So we have to again create this x and y, and we have to plot this one. I am going to copy this. I request you to write it for your own. Now I do not want GDP per capita, instead I want social support. So I'll write that, and the y one will be maximum infection rate, and we'll plot this one. Okay, I again made some error. What is the error that I made in this one? We have to see. So okay, so in social support, s is a small. You have to make sure that you are typing the correct names. See, I am seeing a positive number, I mean positive change, but reg plot will help us better to find that. So I'm just going to copy it down, and I'll paste it over here, and I'll run it. Yeah, there's a positive sign, but not too much. I mean social support is definitely a positive sign, but not too much. It is initially it was, but later when social support increased, maximum infection rate also increased. Okay, so not a very drastic change, I mean with not a very stagnant, I mean not a very sharp increase in maximum infection rate, but yeah, some increase is there. So social support is also increasing the maximum infection rate. Now health life expectancy. So we can again copy this, and we can again paste it over here. Now I'll remove social support, and I'll write it down, health life expectancy. Where is health life expectancy? Here it is. We'll copy it down, and we'll paste it, and I'll print it again. Now what mistake I did, I have to find again. So x is healthy life expectancy. Okay, there's this thing. When I copied it, I made some mistake. Okay, now reg plot will again help us to find that line, that common data between the two. Let's do that. So here also a positive change, which means that healthy life expectancy is also helping maximum infection rate. Now freedom to make life choices. This is very important for any of the countries, that the individuals, the civilians can make decisions for themselves, can decide what life they want. That is also very important. Okay, now let's plot the graph. Here it is. Now we'll use reg plot again for the last time. to find out whether there's a positive change or not. Not very much. I mean, there's a positive change, but this is not that much affecting. So if an individual in a country is free to make life choices, it is not affecting the maximum infection rate that much. Little bit it is affecting. Maybe possible that in the coming months, for example, if we would have analyzed for 4 months, it would have gone till here, which means I mean the growth would have been higher or maybe lower, we do not know, but for this time frame it is not affecting that much. So this is what we did. I mean, this is what we finded, that maximum infection rate in our country is very much increasing for those countries where the country is more developed, where the country have these kind of I mean features such as GDP per capita, where which country has more GDP per capita, maximum infection rate is increasing. The country which we have social support, the maximum infection rate is increasing. The country which have healthy life expectancy, the maximum rate infection is increasing. Though freedom to make life choices is not affecting that much. So we can make this conclusion from the analysis that we did, is that if we have a developed country as compared to any non-developed country, then it has definitely more number of cases as compared to any underdeveloped ones. So this was the project, the video. I request you to definitely subscribe to the channel for more such coming projects and videos. Also I want you to practice this dataset on your own. So we have this practice dataset which is maximum number of deaths. You will find that in the link in the description as well, and I want to predict for yourself. And when you will do that, do not forget to record a video of 1 minute or 1.5 minute, and definitely post that on your Instagram that I did this analysis, and definitely tag us into that particular video. So this was it for today's video, guys. I hope you guys enjoyed it, and I'll see you guys in the next one.
Life has become, you should know.